Aaron is accompanying Darren to look for roses for his date on Valentine's Day.
Wah. Got two shops selling roses. To know which shop cheaper.
Then you ask La.
One rose how much?
Oh, very cheap, $10 for one rose.
Hello. How much you sell your rose?
I see you so nice, I give you 10% off my original price of $10. So I charge you $9.
Boy, come back. I see you still student, I charge you cheaper. Give you 20% discount. So I charge you $8.
Wah, so good ah.
Boy, don't listen to that uncle. I give you extra 10% discount from just now. And I give you a magic perfume. Spray already, the girl confirm like you.
Wah. Vendor be like have better deal. 10% plus 10% means total 20% discount. Then still have magic perfume. Super worth it.
Bro, vendor be trick you. She giving you 10% discount on top of the original 10% she gave you earlier. Means she's giving you 10% off $9. So she's charging $8.10 for the rose. Come, let me show you how I worked that out. The first discount is 10% off the original price of $10. So the new price of the rose after the first discount is $9. Then vendor B gives another 10% discount. This 10% discount is off the price after the first discount, which is $9, not the original price of $10. So the final price after all the discounts is $8.10. You see, 10% of the original price of $10 is not equal to 10% of the price after the first discount, which is $9. So you cannot anyhow add the discounts and say the total discount is 10% plus 10% equals 20% off the original price. So, this is how to calculate the final price of the rose sold by vendor B. First, we calculate the price of the rose after the first discount. Take 10% off the $10 price, that would make the rose $9. Then we calculate the price of the rose after the second discount. We can calculate this by taking 10% off the discounted price of $9. So the final price of the rose sold by vendor B is $8.10. The discount given by vendor B can be calculated by taking the difference between the original price of the rose, which is $10, and the final price of the rose, which is $8.10, divided by the original price of the rose, which is $10, multiplied by 100%. This gives 19%, not 20%. You see, vendor A gives 20% discount straight. So means vendor A selling you the rose for $8, whereas vendor B only give 19% discount. So vendor B selling you the rose for $8.10. Compare $8 to $8.10, vendor A cheaper than vendor B. And please la, magic perfumes don't exist. Vendor B is just trying to scam you.
Oh yahoo. Wah, lucky have you. Okay, I buy from vendor A better.
We've all learned from Darren's mistake, haven't we? Now let's try this problem and not make the same mistake. In 2009, Peter was given a pay rise of 5% and in 2010, he was also given a pay rise of 5%. Is his total pay rise 10% over the 2 years? Justify your answer. Let's see if this question is similar to Darren's situation in any way. Maybe we can use this similarity to help us with this problem. In Darren's situation, vendor B gave Darren 10% discount off the original price, and another 10% off the discounted price. Since the base prices are different, we cannot say the total discount given is 10% plus 10% equals 20%. Now in Peter's case, do you think a 5% increase on his original pay, plus another 5% increase on his pay after the first pay rise, means Peter gets a total of 10% increase from his original pay. The original pay is not equal to the new pay after the first pay rise. So, 5% of the original pay is not equals to 5% of the new pay after the first pay rise. Hence, we cannot say the total pay rise is 5% plus 5% equals 10% increase of the original pay. Now, let's illustrate Peter's scenario with some numbers to help us see clearly. Let's say Peter's original pay is $1,000. Let's use models to help us visualize how to calculate Peter's pay rise. Here is a rectangular bar representing Peter's original pay. Then Peter gets a pay rise of 5%. Using the model, we can simply add one small rectangular bar to represent the pay rise of 5%. This pink bar represents Peter's pay after the first pay rise. The pink bar is longer than the green bar. This shows Peter's pay after the first pay rise is greater than before. Here's how we can calculate Peter's pay after the first pay rise. Take 105% of his original pay of $1,000. This gives $1,050. Then Peter gets a second pay rise of 5%. Using the model, we can add one small rectangular bar to the pink bar to represent the pay rise of 5%. Do note that this small white bar, depicting the first pay rise of 5%, is different from the small blue bar, depicting the second pay rise of 5%. This is because the white 5% bar is based on Peter's original pay, while the blue 5% bar is based on Peter's pay after the first pay rise. This orange bar represents Peter's pay after the second pay rise. The orange bar is longer than the pink bar. This shows Peter's pay after the second pay rise is greater than before. To calculate Peter's pay after the two raises, we can take 105% of his pay after the first pay rise, which is $1,050. This gives $1,102.50. We know that Peter's original pay is $1,000, and his pay after the two pay raises is $1,102.50. We can use these information to calculate how many percent did Peter's pay rise from his original pay of $1,000. That would be the difference between his new pay of $1,102.50 and his original pay of $1,000, divided by his original pay of $1,000, multiplied by 100%, giving 10.25%. You see, the total pay rise is 10.25% and not 10%. You cannot simply add all the percentages up, in this case 5% and 5%, and say that is the total pay rise. Now that you have understood the concept, let's go back to the original problem where Peter's original pay is not given. So let Peter's original pay be X dollars. Previously, when we assigned Peter an original pay of $1,000, we did 105% times $1,000 to calculate his pay after the first pay rise. Similarly, now that Peter's original pay is X dollars, we also take 105% times X dollars to calculate his pay after the first pay rise. This gives 1.05 X dollars. In the case where Peter was assigned an original pay of $1,000, to find the pay after the second pay rise of 5%, we did 105% multiplied by the pay after the first pay rise. Similarly, in this case where Peter's original pay is X dollars, we also take 105% times 1.05 X dollars, giving 1.1025 X dollars. This is Peter's pay after the two pay raises. We know that Peter's original pay is X dollars, and his pay after the two pay raises is 1.1025 X dollars. So the total percentage increase in pay is the difference between his new pay of 1.1025 X dollars and his original pay of X dollars, divided by his original pay of X dollars, multiplied by 100%, giving 10.25%. so these workings can justify why the total pay rise is not 10%.
Let's try out a couple of problems now. In 2009, John was given a pay cut of 5%. In 2010, he was given yet another pay cut of 5%. Calculate his total pay cut over the 2 years. Doesn't this problem sound familiar to Peter's situation? Now it's your turn to try this problem yourself. Here are several questions to guide you along this problem. Great job with the previous problem. I'm glad you have understood the concept of how to deal with problems that involve the adding of percentages. Now let's try another problem. La La Land has a happiness index of 100. In 2017, La La Land's happiness index decreased by 15%. In 2018, La La Land's happiness index increased by 5%. What is the change in La La Land's happiness index over the 2 years? Here are some questions to guide you along this problem. Great job for attempting all these questions by yourself. Here's a summary of what you have learned in this video. When adding percentages up, we must be mindful of the bases used to calculate the percentage. If the bases are the same, we can simply add the percentages up. However, if the bases are different, just like in Darren's, Peter's and La La Land scenario, we cannot simply add the percentages up and say that is the total change. Instead, we need to perform some calculations before we can find the overall change in percentage. Just like what we have done in Darren's, Peter's and La La Land scenario.